The final force we have not yet studied is friction. What we do know about friction is that there are two types, static and kinetic friction. We know static friction is present when an object is stationary, and kinetic friction is present when an object is moving. The thing we haven't studied yet is what affects how much friction exists between two surfaces. So think about in your real life. When is there less friction versus when is there more? Perhaps it helps if you're thinking about walking. When are times when things seem slippery? Well, ice is something that is slippery versus the floor being something like a tile floor is maybe not as slippery. So maybe you have an idea that it has something to do with the types of surfaces in contact. You could also think of maybe if your shoes have good grips on them or if they don't. If they don't have good grips, that means it's more slippery, so there's less friction. But that's not the only thing that affects the amount of friction. Friction is also affected by how much an object is, I kind of put in parentheses, pressed down on the surface. So in other words, if you were to push down on something while you're trying to move it, there would be more friction and it would be more challenging to move than if you didn't push down on it. The reason that friction depends on these two things can be seen with the equations for friction. On our left, we see our equation for kinetic friction, or F sub k. It's equal to the coefficient of kinetic friction times the normal force. That's what that mu sub k is. That's kind of that funny looking symbol that you see right here. That's a mu, or a Greek letter, and it stands for the coefficient of friction. Coefficient means it's just a number. It has no units, and it's related to the surfaces that are in contact with each other. If we have a large coefficient of friction, those surfaces may be rather rough. So like if we were to rub two pieces of sandpaper against each other, their coefficient of friction would be very large. Or maybe if we have good rubber-soled shoes on carpet, that would be a large coefficient of friction. Whereas let's say that we had slippery shoes on ice, that would be a very small coefficient of friction. The other thing this force depends on is the normal force that the surface exerts on your object. That's why how much the object is pressed down on the surface affects how much friction is present. You'll notice something different in our equation for static friction. It has a less than or equal to sign in it. The reason for that less than or equal to sign is that the amount of static friction that is present depends on how much force it is opposing. So if I'm pushing a box that's not moving, if I push a little bit harder and it still doesn't move, I'm increasing the force of static friction in order to keep my free body diagram balanced. We'll see several examples of that in class. If we have an object that is just barely about to start moving, then we will say that it has a maximum force of static friction, and that less than or equal to sign will become an equal to sign, and it equals the coefficient of static friction times the normal force. The coefficient of static friction, much like the coefficient of kinetic friction, is a number without any units and depends on the types of surfaces that are in contact. One important fact is that the coefficient of static friction is always greater than the coefficient of kinetic friction. We'll put these equations to use in class as we apply them to problems with friction.